Hello everyone, and now we are going to understand about the types of bolted connections and types of failures in the bolted connections. So like riveted connections, there are two types of bolted connections, lap joint and butt joint. So lap joints are those joints in which two members are overlapped and connected together. It may be single bolted or two bolted joint, or even it can be three bolted joint. It depends on the number of rows of bolts that be provided in lap joint. Now in lap joint, what happens that the loading axis of members do not match because one member is here and another member is here. So axis of both the members are not coinciding. So the loads applied are at eccentric distance. So due to these eccentric loads, there is uneven stress distribution, and due to which there is development of moment M equal to P times E, which tries to bend the joint in such a way that both the load come along the same axis, but the joint get rotated or bent. So there is bending of joint happening in this case due to the formation of couple. And the bolt may fail in tension in these cases because due to the bending of joint, the joint become inclined and there is development of tensile forces also along with the shear forces. So we recommend that at least two bolts must be used in lap joint. Alright. So the next comes is the butt joint, and in butt joint there is no problem of development of bending moments because the members are placed end to end, and to join them cover plates are provided in two ways. Either we provide single cover plate butt joint or we do double cover plate butt joint. Alright. So in case of double cover plate butt joint only, not in the single cover plate butt joint, because in single cover plate butt joint there is one shear plane. Now what is this shear plane? I will explain you very soon. Whereas in case of double cover plate butt joint, we have the benefit of having two shear plane. Because of having two shear planes, double cover plate butt joints are better than the lap joints or the single cover plate butt joint. And due to this, shear force in double cover plate is half of the shear force in lap joint, and therefore the shear strength of double cover plate becomes the twice of the shear strength of lap joint. This will become very clear when you will understand the shear plane. Alright. And there is no problem of bending in double cover plate butt joint as such. Now this is the isometric view of lap joint, where you are seeing two steel plates or two steel flats are overlapped and holes are made in both the plates, and this is the axial load applied on both the members. Now this is the top view of the lap joint. See, this dotted line represents the end of the lower plate and this dark line represents the end of the upper plate. Alright. So this is the cross-sectional view of lap joint, and in this we have made only one row of bolting. So this is single bolted lap joint, and this is the direction of forces. Okay, and in this case we have provided two rows of bolting. So this is double bolted lap joint, and we can observe the distance E between these two axial forces which are eccentric. So the joint became eccentric joint. Okay, and due to this the joint tries to rotate in this direction so that the forces become concentric and pass through the same axis, isn't it? You see this? But what is the problem in it? The joint become inclined, and due to being inclined joint there is chances of development of tensile stresses also. So bolts may fail in tensile stress also. Now let us come to the butt joint. So this is the isometric view of single cover butt joint. This is the cover plate which can be of inferior quality because the main purpose of cover plate is not to resist the load. and these plates are called main plates. Okay, and main plates are of superior quality because they resist the axial loads. Okay, so this is the direction of forces applied axially on butt joint. So in this case the forces are concentric. Okay, so there is no any chance of development of bending moments in it. And this is the top view of a butt joint, and in this we have done only one rows of bolting on each of the plates. This is the plate number 1, this is the plate number 2. On both these main plates we have provided one cover plate. Okay, so this is the cover plate whose boundaries are shown by the thick lines. Okay, and on each plates we have provided one row of bolting like this. So this becomes single cover, single bolted butt joint. Okay, and if we provide two rows of bolting, then that becomes single cover, double bolted butt joint. So instead of making single cover plate, we also provide another cover plate at the bottom also, and that becomes double cover single bolted butt joint. And this is more stable. And this is the top view of double cover single bolted butt joint, and this is the cross sectional view. This is the top view and cross sectional view of double cover double bolted butt joint, because there are two rows of bolts on each of the plate. Okay, now this is the diagram of bolts in single sear and in double sear. See, in case of lap joint or single cover plate butt joint, the bolts are subjected to single sear. As we have discussed, the unfinished bolts carry the forces, or the force transfer mechanism is by shear or by bending. So the bolts are subjected to shear. Just like you see, this is the plate number 1 and this is plate number 2. And both these plates are subjected to axial forces P. So what will happen due to these forces? If we increase the load, what will happen to the bolts? So one point will come when the nominal shear stress applied on the bolt will increase the shear capacity of bolt. So in that case there will be shear failure of bolt, and this is the diagram of shear failure of bolt. What had happened? The bolt has cut through this plane. You see this plane? This plane is the shear plane, because at this plane the direction of force is towards the left at the bottom and towards the right at the top, है ना? फोर्सेस की डायरेक्शन क्या है? इस प्लेन पे एक तरफ राइट साइड में और नीचे के तरफ लेफ्ट साइड में. And if we go on increasing the value of axial load P, so this will cause shear failure of bolt when the load will exceed the shear capacity of bolt. Okay, so this is the shear failure of bolt, and in this case the bolts are subjected to single shear because there is only one shear plane. Now what is the shear plane? Shear plane is the cross sectional area of bolt. This is the diameter of the bolt D, and this can be net diameter or the gross diameter. So this is the shear plane. Okay, now the area of shear plane depends where it lies. If shear plane lies in shank region, okay, then we have to use the gross area, which is equal to pi d square by 4. And if the shear plane lies in threaded region, the area of shear plane equal to A net, and it will be equal to 0.78 pi d square by 4. Okay, so this should be very clear to you that where is my shear plane going to lie, in the shank region or thread region. So this was about the lap joint, which is in single shear. Now in double cover plate butt joint, you see this case. In this case the bolt is subjected to double shear. Now in butt joint, you see this is the top cover plate and this is the bottom cover plate. And between these two cover plate, this is the main plate 1 and this is the main plate 2. And both of these plates are applied with axial load P, which is concentric. Now we see there are two planes on each bolt. This is plane number 1 and this is plane number 2. Similarly, on this bolt, this is plane number 1, this is plane number 2. So there are two shear plane on each bolt in double cover butt joint. So in this case, the shear stresses will be half. Okay, you see this P by 2 value, because there are two shear plane, whereas in case of lap joint it is equal to P if you do equilibrium of forces. Okay, so the shear strength of lap joint is equal to 1 by 2 of double cover butt joint. Okay, hence the butt joint has twice the shear strength of lap joint. Is it clear to you? So in butt joint, bolts are in double shear. So this is very important to understand. So now we can conclude that total number of shear plane in case of lap joint is equal to 1. Whereas total number of shear plane in case of butt joint is equal to 2. Is it clear? I am demarcating this boundary for lap joint and butt joint. Okay, so in case of lap joint, these two conditions are possible. When we use net area, then we have to put gross area is equal to 0. Okay, or if we use gross area, then we have to put net area equal to 0. So it will be given in the question or it will be shown in the figure that which of the area we have to use. So we have to put the other area equal to 0 in the calculation. So either of these two areas value we have to use in our problems. But in case of butt joint, there are three possible cases. Okay, and when we use gross area is equal to twice of pi d square by 4, because there is two shear plane, then we have to put net area is equal to 0, because we have already considered two gross area of shear planes. Or if we have used twice of 0.78 pi d square by 4 or the net area, then we have to put gross area equal to 0. And the third possibility is that we can use gross area is equal to pi d square by 4, then we have to also use net area is equal to 0.78 pi d square by 4. So you see, in all three cases we have used only two shear plane. In this case we have used two shear plane of gross area. In this case we have used two shear plane of net area. In this case we have used one shear plane of gross area and one shear plane of net area. Alright, now let us come to the failures of bolted joint. So there are 6 types of failures of bolted joint. The very first type of failure is the shear failure of butt joint, which we have just seen right now, because the bolt cut through the shear plane, and in single shear it is the single shear failure, whereas in case of double shear planes the bolt fails in double shear failure. Okay, and single shear failure mainly occurs in the lap joint and double shear failure occurs in butt joint. This is clear to us. And shear failure occurs when shear stress in bolt exceeds the nominal shear capacity of bolt. You understand this? Now this we have already understood. Now let us come to another type of failure of bolt, and this is called bearing failure of bolt. And along with this I have also written bearing failure of plate. So bearing here means compression. And both these types of failure, bearing failure of bolt and bearing failure of plate, are common in the case of lap joint and butt joint only, because these type of failures do not occur in the case of HSFG bolt. So whatever we are studying in this video are only confined to the unfinished bolt. Okay. So bearing failure of bolt and bearing failure of plate can occur depending on which one is weaker. See, in joint there are two things. One is the plate and one is the bolt. If plate is of inferior quality and bolt is of superior quality, and if we increase the load, what will happen? Bolt will not fail. The plate will crush. Okay, because plate is of inferior quality, and vice versa. If the bolt is of inferior quality and plate is of superior quality, and if we increase the load, then what will happen? The plate will not fail, but instead the bolt will get crushed. And this crushing of bolt or the plate is the bearing failure of plate or the bearing failure of bolt. And if both the things are of inferior quality, then both of them will fail partially. So in this case, what happens is that the bolt get failed like this. You see this picture? This is the crushing of bolt. This is the formation of bending like shape in the bolts. Bolt has not seared apart. Just like in Seer failure, what happened? That bolt was cut through the Seer plane. In this case, bolt is not failing in Seer planes. What has happened? The plates have crushed the bolts in this direction of force. Because in this direction there was too high pressure applied. Okay, P was very high. Okay, similarly plates also get crushed. So this is the diagram of bearing of plate and bolts. In this case the bolt hole was here. Now the plate has started crushing, and due to which the bolt has moved from its original position of hole to here. You see this? Okay, so this is the example of crushing of bolts and plates. This is the diagram of single shear failure of bolt in lap joint, and this is the diagram of double shear failure of bolt in butt joint. You see, failure at two planes has happened, and in this case failure at one single shear plane has happened. Now let us come to the next type of failure, which is the tension failure of bolt. Now tension failure of bolt will occur when the tensile stress in bolt increases the permissible tensile capacity of bolt, and this failure will mostly occur at the root of the threaded portion, because that is the most weak section in the bolt. And in this case the bolts are loaded with tensile forces, and they will exactly fail like we have seen in the labs failure of specimen under tensile elongation test of ductility. We have seen how there is neck formation, and we have seen the fracture of the specimen. Like that, bolts get fractured under application of tensile forces. So the next type of failure is the tensile failure of plates. Now the plates may also fail under tensile stresses, and this is also called tearing or rupture of the plate. Okay, and I have shown you the notation of tensile failures, which I generally do. So in plates we provide holes for connection, and due to these holes there is reduction in net effective area of plate. Initially the cross sectional area of plate was width times T, where B is the width of the plate and T is the thickness of plate. Now after providing N holes in the plate, the width will reduce. So the final area of cross section of plate at critical section will be equal to width minus N times diameter of hole D naught multiplied by thickness of plate. So we can see there is a reduction in net effective area of plate. So the tensile failure of plate can occur at the critical sections. So that is called the tearing of the plate, and it can be prevented when we provide fewer holes, less number of holes, and better if we change the pattern of bolting from the chain pattern to the diamond pattern, and even from diamond to the staggered. Okay, So by manipulating the pattern of bolts, we may also reduce the chances of tensile failure of plates. This we have already discussed. And in this case, plates break along the bolt line. Okay. Now the next type of failure of plate is the Seer failure of plate, and this is due to insufficient end distance. Now what is end distance? This is the distance from end of plate from center of the hole measured along the direction of force. Like if we have a hole in a plate very near to the edge, okay, so this is the center of hole and this is called the end distance. You see this? This is represented by letter E also. And if the value of end distance is less than what is recommended in the IS codes, then there are chances of Seer failures of plate. This is the diagram of Seer failure of plate. In this case, we see the value of E is very less, end distance is very less. So the plate is failing in Seer here. So you see the crushing here. Okay. Now how to prevent Seer failure of plate? By providing sufficient end distance. Alright. Now the last type of failure I have kept is the block failure. This type of block failure we will be studying in upcoming units also. So I will just give you a glimpse. So block failure is also known as Seer block failure. It is a combination of Seer failure and tensile failure of plate. Okay. So in this diagram you see a portion of plate which is known as block is getting teared apart from the joint. Now you just look at this diagram. We have applied the axial force here on the member and this was the joint earlier, and what had happened in this case that this block has got separated, okay, from the joint, and this is called a block failure. Now why did this block got separated from the joint? Because of two types of forces that is developing on the edges of this block. So if you look at this horizontal edge of the block as well as the member, there are shear forces developing on the edges. Whereas if you look at these vertical edges of member as well as block, there is development of tensile stresses. So this vertical edge has failed due to tensile failure, and this horizontal edge has failed in shear failure. So block failure is a classical example of combination of shear failure as well as tensile failure. So this is the diagram of tensile failure of plate which is occurring along the bolt line, and this is the diagram of block shear failure in which the block has got separated from the joint. So this was all about different type of joints and different types of failure of joints in bolted connections. So based on these failures of joints and bolted connections, we will be designing bolted connections, and that we will be discussing in upcoming videos. So till that, stay tuned and stay safe. Thank you.